So there's always this level of uncertainty attached to our conclusions for a hypothesis test, which is why it's stated in terms of some sort of, based on some sort of significance level. And the reason why there's this uncertainty and errors that can arise is because we are obviously basing our results on a sample, not of the whole population. Obviously, if we knew every bit of information of the whole population, we would know the true value of the population parameter. So that means we wouldn't actually have to perform any hypothesis tests on what its possible value could be. So that is why when we are working with any statistical inference, whether it be confidence intervals or hypothesis tests, we're never 100% certain of our results, and that's because there are these possible errors that can arise, because we're basing the results on a sample, okay? And it's obviously possible that the sample is not representative of the population, but when we actually perform that test or this hypothesis test, we never truly know. We never truly know if the sample is appropriate or if our results are accurate or not. So that's the unfortunate part about working with statistical inference, but that is also the purpose of statistics and using the different techniques that we have, is because it accounts for these possible errors. So do you remember the names of the types of errors that we can perform? They're not actually too difficult to remember. They shouldn't be too difficult. They're very basic. Anyone want to give me an example of the types of errors?
Type 1 and type 2 error.
Thank you. So that should be very simple to remember. And this table then just nicely summarizes when a correct decision is made or when an error is made. So if we look at the first column, that gives us what's happening in reality. So the null hypothesis can be true, or the null hypothesis can not be true. But remember, we will never actually know exactly if this is which result is correct. We'll never know in reality whether the null hypothesis is true or if it's not true. I mean, that's the purpose of then carrying out these hypothesis tests, is to sort of get information based on our sample to see if there's evidence if it's true or not. And then the first row then contains the result of the actual hypothesis test. So we know that at the end, our conclusion could be either to not reject the null hypothesis or to reject it. Now, if the null hypothesis is true in reality and we have not rejected it, that's obviously a correct decision. So our hypothesis test has resulted in a correct decision. However, if it's true in reality, but our result, our conclusion about the hypothesis test is to reject it, that's a type 1 error, okay? So that is, the null hypothesis is true, but we have rejected it and therefore concluded the alternative, then that is a type 1 error. In reality, if the null hypothesis is not true and we do not reject it based on our hypothesis test conclusion, that then results in a type 2 error. So if the null hypothesis is not true, but it's not rejected, that's now another error, type 2 error. But if the null hypothesis is not true and it is rejected, that obviously leads to a correct decision, and that obviously would be an accurate result of this hypothesis test. Okay, I see some students saying they can't see the table. Okay, let me share my screen again. All right, there, can you see it now? Can everybody see the slide in front of them that has this table?
Yes.
All right, thank you. All right, so we have these 4 different scenarios, and 2 of them would result in a correct decision and 2 would result in an error. Can anybody tell me from Stat 130 which error is seen as a more serious offense? So obviously we don't want to make any errors, but there's always this chance of an error being made, which I'll explain further a bit later. But which error is sort of the more problematic one to make, one that we really, really do not want to make compared to the other?
I think it is type 1 error.
Correct. So the type 1 error is seen as a more serious offense. The reason being, remember, when the null hypothesis is, say, not rejected, so if we're looking at this point here, so when the null hypothesis is not rejected, statistically it means we just do not have enough evidence to conclude otherwise. Okay, we do not have enough evidence to reject our assumption that the null hypothesis is true. So, and this is something you would have your lecturers would have emphasized to you in Stat 130, or hopefully, that when your null hypothesis is not rejected, it doesn't mean we accept it. Okay? When it is not rejected, it simply means we have insufficient evidence based on our sample to conclude otherwise. And what we actually do in reality when say clinical trials are carried out or some sort of studies carried out where we have to use statistics to analyze the results, when they get to the point of this null hypothesis not being rejected, which means we cannot conclude the alternative, it just means that it's an insignificant result. And what would happen in reality, we would either have to perform the study again. So we take now another sample and perhaps even a bigger sample, because the bigger the sample, the better. And then generally the experiment or the study would be repeated, okay? Under maybe more strict conditions, maybe they would perform it a slightly different way to increase the power of the test. But that's exactly what happens in reality. Basically, based on that particular study, we cannot conclude anything. We cannot conclude that the null hypothesis is true, and we cannot accept that it's true. So that's okay. That just means then that it might have been a bit of a waste of resources if that study was carried out, but the null hypothesis was not rejected. It just means that there's an insignificant finding, and then they might just have to use more resources to perform the study again on another sample or bigger sample. But when the null hypothesis is rejected, remember that means it's rejected in favor of the alternative. So that means we conclude the alternative. Now that's a problem, because the alternative is something that basically we base our decisions on. And in reality, it's what drives policymakers to make their decisions. It informs all stakeholders of maybe a particular decision that needs to be made, or some sort of program that needs to be implemented, or some medical drug that then can be released onto the market. So when the null hypothesis is rejected, that means there is a significant finding. And that significant finding then informs people of then what to do next. And that means if a type 1 error was made, and then there's the significant finding that basically we say is the result, that leads to further decisions which can impact people's lives. And that is why this type 1 error is much more serious compared to a type 2 error. So a type 1 error leads to further procedures that can be put in place, further decisions that can be made, and programs that can be implemented. So if you're making an incorrect decision based on a type 1 error, that can lead to many serious problems. Okay, obviously it's a more serious offense. okay, can lead to actual policies that can be implemented that can actually not be correctly implemented. All right, so that's why type 1 is seen as a more serious offense compared to type 2. Okay, type 2 just means, all right, maybe some money and resources were wasted and that's about it. But generally, lives are not impacted as much as if a type 1 error were made. Now, as I said, ideally, we would like to perform these hypothesis tests so that there are no errors that are ever made. But that's not possible because these two errors, type 1 and 2 errors, sort of work opposite to each other. So that when you increase the probability of type 1 error, that decreases the probability of type 2 error and vice versa. So we can never set the probability of making one type of error without highly inflating the probability of making another type of error. So it is for this reason that we, rather than just focus on the probability of making a type 1 error, because it's the more serious offense. And do you remember what we then set this probability of making a type 1 error to? What do we make it equal to? What's its general name that we make it equal to when we perform a hypothesis test? Anybody know? What do we call it?
We set it to equal to alpha.
Correct. Okay, alpha. And alpha is our pre-specified level of significance. Okay? So that is what our level of significance is. So whatever hypothesis test is ever carried out, there's always this level of significance. Okay? It's because we set our probability of making a type 1 error to something as low as possible so that we can then control the probability of making this more serious error. And then we perform the hypothesis test accordingly. And then we usually set alpha to 1%, 5%, or 10%. So those are generally our 3 different types of level of significances that we could work with. And generally, it's the converse of it generally means that's the level of confidence we have in our results. So if alpha is 5%, then that means we have 95% confidence in our results. Okay, so obviously the lower alpha is, the more confidence we have in our results. All right.